Hello, hi, and welcome back to my channel. In today's video, we are going to learn about the room persistence library, and we will see an example of it by creating an application. But before that, let us first understand what it is and why we need it. So as you can see, this is the official documentation provided by Google, and it says that app that handles non-trivial amounts of structured data can benefit greatly from the persisting the data locally. The most common use case of this is to cache the relevant pieces of data locally when there is no network available. So most of the, I would say 90-95% of the applications that you use, which uses the internet to access some data, uses some sort of cache mechanism. And if, let's say, the data that you're trying to cache is of non-trivial structured data, then in that case it is much needed library, because if you're using SQLite, you can do so, but that would be very difficult to handle it in the long run. So what the room persistent library does here is it provides an abstraction layer on top of the SQLite, and therefore it has some advantages over SQLite. So as you can see, these are the three basic advantages, which is that is compile time verification of SQL queries, convenience annotations that minimize repetitive and error prone boilerplate code, streamlined database migration paths. So if you have used earlier the SQLite, you will understand that we need to do a lot of configurations, and there are a lot of queries and securities and concerns and all those things that we need to take care of. But room is better in the sense that it removes most of the boilerplate code, and it provides easy data migration and also a lot of functionalities to keep your data secure. So without further ado, let's jump straight into the example and try to understand how we can use room to our advantage. So the first thing that we need to do here is we need to add some class paths, some dependencies. So I'm using hilt also along with the room. So for adding the hilt, if you haven't seen the my previous video, please go check it out. That will make a lot of things a lot clear. So these are some dependencies that you need to add in the application project level build Gradle file. And apart from this, in the build Gradle, you need to add some plugins, and also these are the dependencies that are required by Tiger, Hilt, and Room. All this data, all this code will be provided in the description. Feel free to check it out. But once you've added all this, once you have synced your project, we can actually start with adding room to our application. So this is a very simple application. What we're going to do here is we're going to create a check-in system where the user can just simply add name and the number of days the client wants to stay, let's say at a hotel or somewhere, and we're going to just save those data. That's it. So the first thing that we need to do here is we need to create some folders. You can create it according to your needs, but for the sake of this example, I've created 3 folders. The first is data, the second is repository, the third is UI. So UI is having all the UI related like the screen related files. The data is having all the room related files, and repository is basically the repository class, which is going to call the functions required. Apart from this, there are 2 more files, which is a module file and an application file. So first things, let us create an application file. So we will create an application file like this, and we will annotate it with Hilt Android application, which makes the application understand that this is an Hilt based Android application. And after this, we will go to manifest and add that particular file over here under the application. Once that is done, we will come back to the main activity. We will annotate the main activity with Android entry point. Okay, now once this is done, we have simply configured our application to use the Hilt. Once that is done, as I said, if you are not clear with Hilt, please feel free to check out my previous video. So once you have done that, come back and continue here. So once we have configured our application to use the Hilt, then what we need to do here is we need to add some room based files. So the first thing that we're going to add is an entity file, which is check-in, as I said. So we create data class. We will have an ID and some name, some days. So these are the two things that we are going to save from the user, and this will be an auto-generated ID. So as you can see, I have annotated it with primary key and auto-generate equals to true. So we need to have one field as the primary key, since that is required for a relational database. And apart from that, we have also annotated the check-in data class with entity and given the table name as check-in. Okay, so this will be a this will be a table which will be called check-in, and these will be our fields. Okay, so once we have done this, we will come to the DAO class, which is basically a layer where we are going to write all our functions that we're going to use, that we're going to call, and we will mention all the queries. We will create this as an interface. So for example, we will be using two functions, I would say two queries. The first one is to fetch all the check-ins that we are saving, and the second is to insert a new check-in. So we will annotate the interface with DAO, and we will create two functions. The first one is to get all check-ins, which will return back the list of check-in. Second is to insert a check-in, which will be a suspended function, and we are going to take the check-in object in the parameter. So for the first one, we will write the query, which is the basic SQL query, where we have written select star from check-in, since this is the table from where we want to get all the data from. And the second is to insert, so we will simply write @insert, and we will mention a modifier which is basically on conflict. So let's say if there is some conflict between the data that we are entering, we will simply replace the older data with the newer data. Basically, we will let's say if we have entered some data which is already there, let's say there is some primary key which is already there, and we have entered another primary key. So instead of throwing an error, we will simply replace that row with the newer data. So after the check-in DAO, we will come back to the check-in database. So after the DAO is created, we will create the database file. So you can see it is an abstract class, and we have annotated it with @database, and entity we have mentioned it as check-in, because this database is having only one table. So that is why in the array we have just mentioned check-in, and this is version 1, export schema equals to false. There are a lot of different optional parameters you can pass, it's totally up to you. And we have added an abstract function which is of type check-in DAO, which will return check-in DAO. Okay, now once this is done, we'll create the repository, and here you can see we are doing dependency injection, where we are asking for the check-in DAO, and we are calling these functions get all items, and we are calling get all check-ins, and in the insert check-in we are calling, or we are using coroutine, and we are calling the insert check-in function. Okay, so till now what we have done so far is we have created two layers. One is data, one is repository. Data is having the model class, the DAO class, and the database class inside it, and repository is taking in check-in DAO as a parameter and calling both the functions that we're going to use, that is get all check-ins and insert check-in. Now we will finally create the check-in view model, which will require the repository. And what we're doing here is we are creating a mutable state flow called underscore check-ins, and which is private. So basically we are going to initialize check-ins with underscore check-ins, and at the time of reading the data, we will simply read this data instead of this. So what would happen, as you can see, we are calling get all items in the init block, and this will hold all the check-ins that has happened. So what would happen, as soon as this is initialized, this function will be called, it will emit the data, it will fetch all those data, and this will also get updated. And whenever we want to use the check-ins value, we can simply use this. So apart from this, we are also going to call this function insert check-in, and we will be calling ViewModel scope launch, and we are calling repository.insert check-in, and then again we are calling the latest data. So initially it will call the data that is already stored, and once we have inserted the new check-in, by calling insert check-in function on the repository, we will again emit with the latest data. Okay. So as you can see, it is pretty straightforward, nothing, no too much complication over here. We just need to mention the class and the dependency that it requires, and we are simply going to use those functions accordingly. So to reiterate, we have created two folders: data repository. Data is having the check-in entity, the check-in DAO class, which is an interface having all these queries inside it, and then we are having a database class, which is basically where we are conferring our database name and all the tables that it will hold inside it. Then we are having a repository, which is calling the DAO class and all these functions. And then we are finally having the ViewModel, which is using the repository to call all these functions so that we can finally use the ViewModel and the UI layer. So once we have done this, what we need to do is we need to create the module so that all the necessary dependencies are provided. So we will create this module called check-in module. As you can see, it is a singleton component, and we have 3 different dependencies that is getting that we are providing from here. So the first one is to get the repository, which takes in DAO and it returns the check-in repository. Second one is to get the DAO, which requires database. So we are calling database.checkin DAO, and it will give back the DAO class. And the third is to actually provide the database, which takes the application context as the parameter. And this is how you initialize your database. So if you are not using HILT, all this is not required. You can simply use this. You can simply create a companion object inside database and simply initialize your database over there. But since we are using HILT, this is what we're doing to initialize the database and give it back. So what would happen here is, what will happen when get DAO is called, and since it requires check-in database, it will get it from here. Now when get repository is called, it requires check-in DAO, it will get it from here. So all the dependencies will be provided, and similarly in the check-in repository, since check-in DAO is required, it will get it from the module. In the check-in view model, since repository is required, it will again get it back from the module. Okay. So for the UI section, what I have done here is I've created a composable called check-in screen, which takes in the check-in view model, and I have initialized it with HILT view model. After that, we are calling collect as state on check-ins provided by the check-in view model, and we are storing it inside the check-ins variable. And we have declared 2 mutable states, one for name and one for days. And as for the UI, what we are doing here is we are having 2 outline text fields, which takes in name and the number of days as the input, and a button, which is basically calling the insert function, that is insert check-in, and we are providing the required parameter by passing the entered value, that is name and days. And after this is called, we are initializing it back to the default values. Okay, so what should happen here is it will click insert check-in, it will insert those values, and once that is done, it will again call back the data that is saved, and this will update, and since this will update, it should be visible. So for displaying the data that is saved, I have created a lazy column at the bottom, which takes in the check-in values and a card. When inside this we have a column which simply displays the name and days. That's it. So let's see how it looks, and that would give you a better understanding of the flow of the application. So this is how it looks. So right now, once the application runs, if there is some data that is saved, there should have been a list of cards at the bottom, but since there is none at the moment, so we are not able to see it. So let's add some data. Let me add my let me add my name, and let's say day is 1. So click on check-in, and you can see it created a card. Again, let us add some random name, let's say, and let's say 12, and it will create another card. So what is happening here is, as soon as I am clicking the new check-in button, it is calling insert check-in and passing this, and once that is called, it is again calling the get all items, and since we are emitting this again, check-ins is getting updated and this is getting called. So as you can see, the cards are there and all, but the main thing that we want to check here is that if the data is still persisting or not. So let's reload our application and check if the data still exists or not. So if we reload our application again, we can see the data is still there. That means that our persisting library room is working fine and we are able to save the data, cache the data locally successfully. So that's pretty much it for this particular video. Hope you got to learn something new about room persistent library, and if you have any doubts, anything that you want to clarify, please let me know in the comment section. Also, I'm providing a link in the description so that if you want to have a one-on-one session with me regarding some consultation or some doubt clearance, feel free to check it out, and I will see you in the next video. Thank you.